So we're going to quickly go through the overview, put it about the time limit. So here we need to learn about a little bit about administering intersite connectivity. So the intersite connectivity works on the VNet peering, network routing, and endpoints. And then if the time permits, we will do the demo on this one, as we will do the demo for the other next session. So configuring VNet peering, where when you created a VNet in one of those region, and you got VNet created in the same region or another region, and you want to make that connectivity, and that's where the peering is going to be useful. You also need to determine, like, how the gateway transit and connectivity needs are happening, and how you're going to create the VNet peering, service chaining usage, and so on. So this is how the VNet peering is happening, and this is a use case. So if I just highlight this here, there are two type of peering is available. It's global and regional. So when it comes to the regional, just imagine this is one single within one region. You're creating multiple VNets, and you connect that to the regional VNet peering. VNet peering, and that's why it's called regional. But when it goes to the different region, so it's connecting inter-region, then it just called global peering. So these are the two type of peerings available, and you can peer across subscriptions and tenants. So just remember on that one. And always this peering network, it uses Azure backbone. So this is internal private network, and that maintains the privacy and the isolation. So it doesn't go on the general public network. It just have private network setup. And it's easy to set up, seamless data transfer, and very good performance, because the internal private network bandwidth is a lot higher than what we have on a public network. So it's definitely going to give you a better performance. Then the transit and connectivity needs, if you have those, you can use this peering. So make sure you understand the peering concept. So transit allows the peered virtual network to share the gateway and get access to resources. No VPN gateway is required in this peering virtual network. So instead of having a VPN gateway, you can just use the peering virtual network, and default VNet peering provides full connectivity. So here is a scenario where I have a VNet 1 and created VNet, so VNet A and VNet B. But in here, I got the hub VNet, and within this, it's create this peering. So this is how it becomes it's a gateway transit. So this is where it's a transiting happening. So it's got the VPN gateway. It's a typical old network, but instead of that, you can use a peering. I hope that makes sense. Okay. To create a VNet peering, you will be giving like another one VNet name, allow all the settings, whatever you need to set up, and wherever the VNet linking needs to happen, and it creates a vice versa. Okay. Service chaining use case, where leverage user-defined routes and the service chaining to implement custom routing. Implementing a VNet hub with a network virtual appliances on a VPN gateway, and service chaining enables you to direct traffic from one virtual network to another virtual appliance. Yeah. So these are the couple of key points you need to remember, and this is how the chaining is happening. So when we're configuring network routing and the endpoints creation, so that's where there are a couple of things needs to be mindful of. So let's assume there is a use case here, which is like, we're running an e-commerce website and there's a backend service, and it needs to be connected to the internet to receive requests to your front-end service, and front-end needs to make a request to backend service to receive all the necessary response. So in this kind of a use case, you can use a system route. So system routes direct network traffic between virtual machines, on-premises network, and the internet. So these are the three locations it's connected. Yeah, and internet. The traffic between VMs in the same subnet is only possible. So between VMs in a different subnet in the same virtual network also possible. And data flow from VMs to the internet is also connected possible here as well. And communication between VMs using VNet to VNet VPN, that is possible as well. Site-to-site VPN and ExpressRoute communication through the VPN gateway is supported here as well. Okay. The same thing, if you put in a user-defined route perspective, what you need in between is the VM appliance IP forwarding. And here, for the when you actually have a VM appliance IP forwarding, you can define the user-defined routes. So the difference between a route table contains a set of rules, so it's called routes, and that specifies how packets should be routed in the virtual network. Now, each route table can be associated to multiple subnet. But a subnet can only be associated to a single route table. Okay, just remember that. So there are no additional charges for creating route table in Microsoft Azure. And do you think you will need to create a custom route? Then this is the route. Okay. We can determine the service endpoint to connect with the route. In the example demo, I did show you where you can actually create the associating the endpoints as well. So you can see the when you're creating any VNet and some of those subcomponent, you can assign like which service endpoint you want to associate it with, whether it's a storage, SQL, or service bus, key vault, or anything like that. Okay. So virtual network service endpoints, it restricts a network across to the past resources with the virtual network service endpoint. That's how you can do it. You can improve the security of for your resources. Optimal routing for your services can be achieved with this one, and uses the Azure backbone, and it is simple to configure. Okay. And identify private link usage. So private link is in many cases is definitely a need. So in this example, and also the previous example we seen it, we got the application server here and we got the database server here. When the request comes in, you don't really need to expose the database server because the database servers can remain behind the scene for these resources to bring all the required calls and making or fetching data or anything like that can be done using a private link. So that means this area, which is more critical to the business, remains secure. So private connected to the service on Azure, traffic remains on the Microsoft network with no public internet access. And that's how the protection is happening. But to access this, you have to have the front end layer, and the front end layer connects. So this is the kind of a use case has been given for the private endpoint. Other private endpoint use case I can give is when you're creating, say, functions or logic apps and so on, you can use a private link to secure those executions and do not expose to the public internet. So that means it just like all the operations remains within the private network itself. You can integrate with on-premise and peer network. And in the event of a security incident within your network, only the map resources would be accessible. So when I say, if someone breaks into it, so let's assume they breaks into the server and gets into, try and connect to the services, they can just only use this private link to get into here, but the other services won't be affected. Okay, so there's a lab objective, which we just going to park for now, and we switch over to another presentation quickly. And that's about